All right, so this is a key to the worksheet on the discriminant. And so on this worksheet, for each of these problems, you are asked for the number of solutions, use the following. So either indicate that there is only one solution or two solutions. And then for the type of solutions, you will need to indicate whether the solutions are real and rational, real and irrational, or imaginary or non-real. And then don't forget, you have to indicate the value of the discriminant. For this worksheet, when you looked at the lessons, you are also provided this chart. So make sure you understand the information that's in this chart. You are going to use this information to help you to determine the type of solutions and the number of solutions. So let's go ahead and look at number one. Okay, so here's number one. Now, keep in mind that you're not asked to find the solutions. You're just asked to determine the discriminant and the number and type of solutions. That's all you're asked to do. So do not use the quadratic formula. Do not, if it's factorable, do not factor. Do not solve these equations. All you're asked to do is to determine the discriminant, the number of solutions, and the type of solutions. That's it. Okay? All right, so first thing, remember that whenever you're going to determine the discriminant, and also if you are going to use the quadratic equation to solve the equation, you have to make sure that the equation is in standard form. So make sure that for each of those problems, it is in this form, ax squared plus bx plus c equals 0. Make sure you see that 0 on the other side and put it in descending order. All right, so the discriminant, remember the discriminant is the expression that is underneath the square root symbol in the quadratic formula. So remember and I'm going to go ahead and put that here. So remember the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So this part right here, this radicand right here, that b squared minus 4ac, that is the discriminant. And so for each of those problems, you're going to use this expression, b squared minus 4ac. All right, so don't forget the discriminant is b squared minus 4ac. And that value right here will determine the number of solutions and the type of solutions. It won't tell you what the solutions are. Remember, that was discussed in the lessons. It will just tell you the number and type. Okay? All right, so when using the discriminant, remember you have to know what the coefficient of x squared is. So that's a, the coefficient of x, that's b, and the constant, that's c. So in this case, a is 2, b is a coefficient of x, so that's negative 2, and c is your constant, and that is negative 3. So in the discriminant, we're going to substitute those values for a, b, and c. So when I do that, I'm going to, remember you're squaring b, so I'll make sure, especially if it's negative, you put that in parentheses because negative 2 is what being squared. So b squared will never be negative because any number times itself, any real number times itself, I should say, is positive or 0, never negative. So negative 2 in parentheses squared minus 4 times a, which is 2, times c, which is negative 3. And so using the order of operations, we're going to do the exponent first. Negative 2 times negative 2 is 4. All right, let's go ahead and multiply this out. A negative 4 times 2 is a negative 8, and a negative 8 times a negative 3 is a positive 24. 4 plus 24 is 28. All right, so the discriminant, so in the discriminant, you're going to say right here, you're going to say 28. All right, so that's the discriminant. Since the discriminant is a positive number, since the discriminant is a positive number, now make sure you understand this column right here. So if the discriminant is a perfect square, which is positive, then you're going to use this information. If the discriminant is 0, then you're going to use this information. If the discriminant is positive but not a perfect square, then you're going to use this information. And if the discriminant is negative, you're going to use this information. But notice 28 is not a perfect square, right? 28 is not a perfect square. So remember your perfect squares are, remember the smallest perfect square is 1, and then the next one is 4, the next one is 9, next one is 16. Remember 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, and so on. So 25, 36, 49, and so on. Okay, so there's an infinite number of perfect squares. But notice 28, no whole number times itself, no integer, no positive integer times itself is ever 28. So 20 is not a perfect square. So since 20 is not a perfect square, positive but not a perfect square, then I'm going to get 2 different solutions, and they will be real and irrational. So 2, they will be real and irrational. So remember your choices. Number of solutions, 2. Type of solutions, real and irrational. So you're going to say 2, real and irrational. Okay? All right, so that's number 1. All right, so then we're going to look at number 2. So number 2, we have 2n squared plus 8n equals a negative 8. So first of all, notice that this quadratic equation is not in standard form. So it's not in the standard form right here. Remember, this is our standard form. And so I need to transform this into that standard form. So I'm going to go ahead and add 8 to both sides. So I get 2n squared plus 8n plus 8 equals 0. And so now it is in standard form. So let's go ahead and determine the coefficients of a, b, and c like we did in number 1. So the coefficient of n squared is 2, so a is 2. The coefficient of n is 8, so b is 8. And the constant is also 8. And so therefore the discriminant, remember, is b squared minus 4ac. So in place of b, I'm going to substitute 8. In place of a, I'll substitute 2. And in place of c, I'll substitute 8. So I get 8 squared minus 4 times a, which is 2, times c, which is 8. All right, now using the order of operations, we know that 8 squared is 8 times 8, so that's 64. A negative 2 times 8 is a negative 8, and a negative 8 times a positive 8 is a negative 64. So I get 64 minus 64, which is 0. So number 2, the discriminant is 0. Well, since the discriminant is 0, you're going to have a double root, a repeated root, so there's going to be one distinct solution. And they will be real and rational. So in number 2, you're going to say number of solutions will be 1. Although there are 2, they're the same solutions. They're going to occur twice, but we're just going to say one distinct solution. And the type of solutions will be real and rational. So real and rational. All right, let's look at number 3. So number 3, we have this equation. We have 2x squared minus 4x plus 7 equals 0. So this quadratic equation is in standard form. It's in descending order, so it's easy to determine a, b, and c. So a is a coefficient of x squared, so that's 2. B is a coefficient of the first degree term, so that's negative 4. And c is your constant, so that's positive 7. The discriminant, b squared minus 4ac, so that's going to be b squared, so that b is negative 4, put in parentheses, it has to be squared, minus 4 times a, which is 2, times c, which is 7. So negative 4 times itself is 16. A negative 4 times 2 is a negative 8, and 8 times 7 is 56, right? So this becomes a negative 56. And so 16 minus 56 will give us a negative 40. Okay? So the discriminant is a negative 40. So you're going to put negative 40 in the blank right here for the discriminant. All right, now notice this time the discriminant's a negative number, right? So the discriminant is negative, and remember in the lessons that went with this chart, you saw that if the discriminant is negative, you're going to get two different solutions, but they're going to be imaginary. They won't be real. There will be none real. Imaginary and none real. So for that one, you're going to say two different solutions, and they're going to be imaginary, none real. So you're going to say two, imaginary, none real. Okay? All right, let's look at number 4. So number 4, we have negative 3x squared minus 6x equals a negative 4. All right, so notice that this is not in standard form, so let's go ahead and add 4 to both sides. When I do that, I get negative 3x squared minus 6x plus 4 equals 0. All right, so let's determine a, b, and c. So a is the coefficient of the squared term, the second degree term, and so that's negative 3. B is a coefficient of x, the first degree term, that's negative 6. And c is always your constant, that is 4. So b squared minus 4ac, the discriminant. So b is negative 6, I've got to square it, just like this, b squared. So negative 6 squared minus 4 times a, which is negative 3, times c, which is 4. So negative 6 times itself is a positive 36. A negative 4 times a negative 3 is a positive 12, right? And so 12 times this 4 right here is going to give us a positive 48. So when I add those two numbers together, I get 36 plus 48, which gives me 84. All right, so I get 84 there. So therefore, now remember 84 is not a perfect square. Keep that in mind. So I'll be 84 right here. All right, so since 84 is positive but not a perfect square, we're this situation right here. So that's going to be two different solutions, and they're going to be real and irrational. So two, real, and irrational. All right, and so let's look at number 5. All right, so number 5. So in number 5, we have negative 15x squared plus 4x plus 4 equal 0. So this is in standard form, right? And so it's the descending order. So a is coefficient of x squared, so that's negative 15. B is a coefficient of x, so that's 4. And c is the constant, so that's 4. So b squared minus 4ac. So in place of b, I'll substitute 4, so that's 4 squared minus 4 times a, which is negative 15, times c, which is 4, right? Well, 4 times 4 is 16. A negative 4 times 15, and if you need to use your calculator, so a negative 4 times 15 is a positive 60. A positive 60 times this 4 is a positive 240. So I'm just using a calculator right here. So you get plus 240, right? But 16 plus 240 is 256. All right, so now you have to determine, and some students don't see this, but you have to determine whether this is a perfect square or not. And so here's the way I would do this. So remember, 9's a perfect square, right? So if I take 9 and take the square root of it, so I'm going to take the square root of 9. So second square root of my calculator, that's how I do this. So square root of 9, I'm going to get a whole number. I get 3. So if I take 256 and I take the square root of 256, let's see if I get a whole number. Oops, let me go ahead and clear that. So second square root, okay, 256. So let's take the square root of 256. When I take the square root of 256, I get 16, which is a whole number. So that means that 256 is a perfect square. Perfect square. And so the discriminant's 256. You can write 256 here. So since the discriminant's a perfect square, that's a positive number, and it's a perfect square, then we know we're going to get two different solutions, and they're going to be real and rational. So two solutions, and they're going to be real, two distinct solutions. They'll be real and rational. Okay, and so that is the answers to the worksheet on discriminant.